Okay, let's go over these questions together because some questions like these two or these three will be exactly on the quiz tomorrow. So now the first thing that we should take care of is that you need to know what information is given to you and how important, how useful the information is. So when they say, well, they tell you explicitly theta is in quadrant 2, so you will be drawing something like this, okay? So something like this, because it's in quadrant 2. Now the fact is it going to be like this or that? Okay, how do we know which one is which? Well, that's why we look at this, and secant theta, it's negative. Does it make sense that secant theta is negative? Why does it make sense that secant it's negative? One of a cosine, right? And one thing that you should pretty much either on your paper or in your mind, I always like to draw it out because I can look at it. I don't have to force myself to think about it in the back of my head. So ASTC, okay, again, these 4 letters represent the function that is positive in each of the respective quadrants. So quadrant 1, all trig functions are positive. Quadrant 2, sine function is positive. Quadrant 3, tangent. Quadrant 4, cosine. And since it is in quadrant 2 and secant theta, it's 1 over cosine, so it makes sense to be negative. And when we say a negative 25 over 24, what is the meaning of this 25 over 24? Hypotenuse over the adjacent. So when you draw your terminal side, now, how would you draw it? I would suggest you to draw it in some kind of way that actually resemble the reality quite a bit. So I would draw something like this. And this is how you draw your reference triangle. Just like your reference angle, it's always between the x-axis to the terminal side. Okay, so that's what we talked about yesterday. So that's your theta, and this is your 25, and this is your 24 on the negative side. And earlier, while you were doing it, I said that 25 squared minus 24 squared is 7 squared. That means the opposite is 7. Okay, the opposite side is 7. And because it's in quadrant 2, we can also go ahead and label the trig functions with some negative sign, except sine theta and cosecant theta. Everything else should be negative. So cosine is 24 over 25. Secant is 25 over 24. Now, it may sound hilarious, but I hope I don't see it tomorrow. Some people will manage to lose a point right here when it's already given. Okay, it's already given. I mean, you just cannot get this wrong. Sine theta, it's 7 over 25. Cosecant is 25 over 7. Tangent theta, it's 7 over 24 negative. And cotangent is 24 over 7. As always, if, well, not in this case right here, but if you find the fraction to be, that could be reduced, that could be simplified, you always simplify. You don't leave anything like 6 over 30 on the paper. You always reduce it to the simplest fraction. You're in pre-calculus right now. That should be a norm. That should be a habit. Okay, any question on 25? On where the numbers are coming from and how you know what you do to get the ratio. Questions? All right, well, number 26. For number 26, the angle, it's quadrant 4. And for quadrant 4, what is positive in quadrant 4, we say? Only cosine, right? So that's why tangent, it's negative. So that makes sense. And what does this 5/7 ratio tell us? Opposite over adjacent. So opposite over adjacent. So when you draw your terminal side, so opposite over adjacent. So something like this. Opposite over adjacent. So so your theta will be right here. And if you do your Pythagorean theorem, this will be square root of 74. Not a nice number. Cannot reduce it. If you could reduce it, you reduce it, but you can't. You can't. So just leave it like this. It's in quadrant 4, so we know something to be negative. Sine and cosecant, tangent and cotangent. They're all negative. All right. Now, you should anticipate a question like this, which you will see a square root, which you will need to rationalize. So when you do your cosine of theta, that will be 7 over root 74, which you will need to rationalize. Now, if you directly write this, if you just write this as your answer, would I take points off from you? I will not. I would not, okay? Because I think you are sophisticated enough to actually do this in your head, okay? So, okay. Sine theta, it's a -5 over, -5 square root of 74 over 74. Okay, cosecant theta will be negative root 74 over 5. Tangent theta is -5 over 7. And cotangent theta, it's 7 over 5. Questions? Now, if you're reviewing tonight, what is the main thing that you want to write something? What's the main thing you want to write down and remind yourself? You look at the information. You ask yourself very honestly, what are you thinking? What ideas do you have when you read this statement? Do you know what to do? Do you know what action you could do? Do you know how to draw the angle? Do you know how to draw a triangle? That's the type of thinking you need to ask yourself. Okay. All right. So same thing. Okay. You have the angle. We want to tell the quadrant, and by doing so, we want to find out whether it's positive, which part is positive, which part is negative. 190 degrees. It is in quadrant 3. That's easy. So in quadrant 3, which function is positive? Tangent and cotangent. All right, I'm not going to put the negative because if you know what is positive, I'm going to take the assumption that you know the other ones are negative. You know the other ones are negative. Ooh, over 15. So how can we tell which quadrant it is in? It is in quadrant. How do you know? Yeah, look at, now, if you remember what I showed you the other day, last Thursday, right? Think about 30 pi over 15 is 2 pi. Look at this number is like, oh, it's so close to 2 pi. So close to 2 pi means quadrant 4. Okay. So, so I think it's right here. Okay. So last Thursday, I gave you this different frames of reference to allow you to tell which quadrant very easily. Okay, you do not convert to degrees to tell. You just think about that when it's pi, you think about 4 pi over 4. When it's 2 pi, you think about 8 pi over 4. And it applies to any kind of fraction with any kind of denominator. You can use the same way of thinking. Okay, so so in this case, we have 30 pi over 15 as 2 pi. 29 pi over 15 would be just in quadrant 4. And that means cosine and secant will be positive. Everything else will be negative. 5 pi over 8, it is in quadrant 2. How do we know it's in quadrant 2? It's slightly greater than 4 pi over 8, which is pi over 2. Okay, slightly greater. So so quadrant 2, meaning sine and cosecant will be positive. So please do well tomorrow. I'm still hoping that there will be a very good quiz to grade so that I can just not write down any comment and say 100, 100, 100. Right now, so 2 questions like this will be on the quiz tomorrow. There'll be a table just like this with different angles in degrees and radians. You write down what's positive, what's negative. If you look at the worksheet from last Friday, okay, there will be questions like 7, 8, and 9. By giving you some conditions, we would like you to tell us whether it is in quadrant 1, 2, 3, or 4. It could be 2 quadrants. It could be just one single quadrant. So you have to state that. There'll be 2 questions. Just like this, we give you a point. You finish the rest. Just like these. Okay? Just like these. So that's why last Friday I said to you, the worksheet from last Friday will be a very good practice for a quiz. Okay? So yeah, so make sure you know how to interpret some situations like this. Like they tell you the sine theta and cosine theta, but not telling you explicitly what the quadrant is. So you need to know how to interpret the quadrant. Okay, like this case, sine is negative, cosine is negative. You think about it, you're like, wait, hold on. When it's sine and cosine both being negative? Quadrant 3. Any question regarding to tomorrow's quiz? All right, now the materials on the front page. The materials on the front page will not be on the quiz tomorrow, but on the quiz next Tuesday. And of course, test is Thursday next week. And then we have Thanksgiving. So what is it? Now, if you look at question 1 through 12, oh, by the way, for question 5, you can ignore the little dot after cotangent. It's not supposed to be there. So you can kind of just ignore it. The dot right here. Okay, so it's just cotangent of 274.994 degrees. So what's something you need to be careful for when you do a question 1 through 12? Louder? Settings. What about the settings? Degrees and radians. Now, I don't expect any problems for these calculations, except that there was one problem that that the student discovered today. I guess yeah. For some reason, this calculator, the trig functions are limited, so you can only do sine, cosine, tangent, and you cannot do cosecant, secant, or cotangent. So you can check your calculator and see if that works. If it works on you, or works on your calculator. If not, We just make sure that we change to another calculator. Okay, so yeah. All right, now, but before I move into these examples, I want to emphasize one thing. I said this yesterday. I want to emphasize this again. You are going to see some numbers. Okay, so if I ask you, what is this number? What is the meaning of this number? Is it what? Is it angle or is it ratio? It is an angle. How do you know it's an angle? It represents theta because this is a regular trig function. We say sine theta, cosine theta, tangent theta. It's a regular trig function. So what you put into a regular trig function? An angle. What about these numbers? For question 13 and on, what about these numbers? And these are the ratios. And if you want to use ratios to find the angle, what do? You do the inverse. So, so now I'm going to give you 5 minutes to work on these questions. I mean, for question 1 through 12, it's just punching the keys into the calculator. That should not be that hard. And then the bottom ones are the ones that we did yesterday. So I'll give you 5 minutes to work on at least 1 through 12. And then we will discuss question 13 and on. Okay, so go ahead. Work on question 1 through 12 for the next 5 minutes. Okay, so you can go ahead and check your answers for question 1, 3, and 5. Question 1, negative 0.731. It's negative because the angle it's in quadrant 2. It's a cosine function. So it makes sense to be negative. Question 3, the answer is negative 0.409. Sine of an angle that's located in quadrant 3, so it's negative. Cotangent of negative 0.15, cotangent of an angle, 278.94 degrees. This angle is in quadrant 4 because it's slightly more than 270. It's cotangent, so it's also negative, which makes sense. 2, 4, and 6. Question 2, tangent of 223 degrees is 0.933. 223 degrees is in quadrant 3. Tangent of an angle in quadrant 3 should be positive. Cosecant of negative 47.8. That means it's in quadrant 4. So 1.350. And question 6, secant of an angle that's in quadrant 3. That would be negative 1.069. Okay, so if you use a TI Nspire calculator, it's pretty easy. You just plug it in. Okay, if you use some old calculators like this one, a TI-84 or a scientific calculator, you may not have the luxury of using cosecant and secant or cotangent. So you have to do the reciprocal manually. Okay, which is fine. Actually, I think that makes people smarter. 7, 9, and 11. Question 7. It's negative 0.383. The angle is in quadrant 3. Okay. Number 9, tangent of negative 5 pi over 7. It's that angle is in quadrant 3, so positive ratio, 1.254. Now, I hope you understand why I kept bugging you, asking you all, like, what's the meaning of these numbers? In the past decade or so, I have taught students about pre-calculus, calculus. The biggest misconception Well, the biggest gap is that students are looking at numbers as if they are just numbers. They don't have the meanings on these numbers. And that's why they couldn't tell what kind of function they do. Okay, so that's usually the problem. So this is an angle, okay? And especially when you don't see any degree sign and you don't see any pi, that could be difficult to tell because that's just a radian. So cosecant of angle in quadrant 3. Okay, how do we know this is in quadrant 3, by the way? How do we know that's in quadrant 3? No. I mean, look at the negative 2.51. How can we tell that angle is in quadrant 3? Now that's what happens after the calculator, but before the calculator, you should know this is in quadrant 3. How? How can you tell? Because if you don't know how to tell, then that's going to be a problem tomorrow. Anybody, any idea? Negative means what? You would count it clockwise, but that could be any quadrant. How can we know this is in quadrant 3 though? It's less than pi, less than 3.14. Okay, so that means we are not going over the x-axis. So it's going to be either quadrant 4 or quadrant 3. Let me write this down so that you can actually see it. So, okay, so you're going backward. You're going backward right here. So, so it's not all the way to the x-axis. So now the question is it quadrant 4 or is it quadrant 3? Now, this is where I said you have to learn how to approximate. If you don't know how to approximate, then it's going to be a problem. What is pi over 2 as a number? Around 1.5-ish, right? And this is, 2.51. So that means it has to be more than that. So somewhere right here. That's how we know it's in quadrant 3. Okay, so ever since we started this trig functions, I told you a few values that would really help you to approximate. For example, do you remember what's the angle measure for a radian? 57.3, right? So if you have that idea, also around 60, but less than 60, right? So you look at this, you're like, oh, wait, hold on. This is 2.5 radians in the opposite direction, in the clockwise direction. So you can tell that's around 150-ish. Then you will also know that it falls into quadrant 3. Do you have those numbers ready to go? That's a key thing. That's the thing I worry the most. All right, number 8. 0.951 for number 8. 2.221 for number 10. And for number 12, negative 0.268. All right, so just make sure that when you do these questions, you change your calculator mode. And the best way to protect yourself, the best way to know that you are in the right mode or not is that you identify these quadrants. Sometimes the sign may not align, and then you know that, wait, hold on. It's in quadrant 1. How come I'm getting a negative value? So then you know you smell something bad and you're like, oh, got a problem. All right, now, so just a quick review of what we did yesterday. What is this again? Ratio. So what does the negative sign tell us? Cosine theta is a negative ratio. That means the theta it's in quadrant 2 and quadrant 3. All right. Now that's the purpose. That's the mission of the negative. Now we want to find out the reference angle. How do you find the reference angle? When you do the inverse, what number goes in here? The ratio. Regular trig function, what goes in there? It's an angle. Make sure you know how to identify the nature of those numbers. Okay. And if you put it into your calculator, make sure you're in the right mode because we were just doing things in the radians. So make sure you're back to degree mode. So 0.903. Oops, so inverse cosine of 0.903. It's 25.448 degrees. Okay. Now that's a reference angle. That's not the angle yet. Our angles are in quadrants 2 and quadrant 3. Now, if you can handle the calculation without drawing a diagram, great. I don't need you to draw a diagram. But if you are somewhat puzzled, you draw a diagram right now. Right now. So that you know what's going on. What's going on right here is that you are having an angle that's in quadrant 2. And this is the reference angle. And then you have an angle that's in quadrant 3. And this is the reference angle. So now, maybe so this is 25.448 degrees. And we are looking for the angle from 0 all the way to here. So how can you find out the angle from 0 all the way to here? 180 degrees minus 25.448 degrees, which is very easy. Now, what I want to emphasize here is this. Please don't be like me in the past. When I was in the past, I tried to memorize when to subtract, when to add. That resulted in total failure. Because if you try to memorize when to add or when to subtract, that means you are not really picturing what it is. But once you have the picture, do you really need to memorize whether to add 180 or subtract by 180? I mean, come on. You're smart enough to get this. So for quadrant 3, it will be, how do you get this big angle? 180 plus. Because that's right next to 180. Right? That's right next to 180. So 180 plus that little reference angle. That's the answer. Don't make it overly complicated. It's possibly easier than you might have thought about at the beginning. So 154.551. And then right, 154.552, sorry, 552. And then you have 205.448. All right, so now for all these, you got 2 answers. Because one answer from quadrant, well, I mean, if it's positive, then you have 2 quadrants. That gives you the positive, answers. If it's negative, like this one, then you have 2 different quadrants. Okay. Now, at this time, I want you to take a look at question 19. It's really the same thing. except that it is in radian. So sine theta, it's negative 0.252. What's the interpretation? What can we interpret from here? Quadrant 3 and quadrant 4 because of the negative. So the reference angle is sine inverse of 0.252. So make sure you change your mode to radian mode. If not, you would likely get a huge number. And again, we don't put the negative right here because the negative has already served its purpose. It told us about the quadrants. So we're looking at the ratio because we just want to figure out what the theta is. So set it to radian, and then inverse sine of 0.252 will give you a reference angle of 0.255. So if you know what's going on, you can go ahead and do the addition or subtraction. But if you have no idea, again, draw pictures. Draw pictures to show yourself what is going on. So we have an angle in quadrant 3. And then we have an angle in the quadrant 4. And that is 0.255 radian. 0.255 radians. So how do we get these two angles? These two big angles. For the one in quadrant 3, we'll do pi plus 0.255. And then you put into the calculator whatever it gives you. It's the radian, 3.397 radians. Right now, I want to pause a moment to make sure that you understand what's going on. If you have no problem for the earlier problem in degrees, then you should have no problem for this one, because the only thing that's different is the representation. The previous one was in degrees, so we'll do 180 degrees plus whatever degrees that we had for the reference angle. And this one is in radians, and therefore we just use radians. Okay, and then for the bottom one, how do we get the actual angle for the bottom one? Well, we'll get 2 pi minus 0.255 radians. So 2 pi minus 0.255 radians, you get 6.028 radians. Again, you have this little piece right here away from 2 pi, so you just subtract. You have a picture, you know what to do. If you want to get the answers for this one, you can turn on your airdrop.